हेलो माय डियर मैकेनिकल एंड सिविल स्टार्स, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? प्लीज गाइस डू जॉइन मी फास्ट बिकॉज वी आर गोइंग टू डिस्कस the most beautiful 10 questions from the kinematics of the fluid flow. So please do let me know if my audio and visual quality are fine so that we can start this wonderful session on time. Yes, please do join me fast. So the series is 10 का दम. क्यों नाम है इस सीरीज का 10 का दम? क्योंकि सिर्फ हम 10 क्वेश्चन डिस्कस करेंगे. And believe me, each and every question will be improve your in-depth understanding of the topics of kinematics. So am I audible and visible to all of you? Please do share do let me know if my audio and visual quality are fine. So for those who are attending my session for the very first time, this is my quick introduction. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi. Graduated in 2006. I have also cleared engineering services examination which is conducted by UPSC. I cleared this examination in 2009. I had worked in Steel Authority of India Limited for a couple of years, and I have also worked in a private consulting firm for more than 2 years. And from the last 10 plus years, yes, I am having more than 10 years of experience guiding the students who are preparing for various competitive examinations like GATE, ESC and other PSUs. And I am very much comfortable in fluid mechanics, thermal engineering, industrial engineering as well as the heat transfer. So fluid mechanics we are discussing in this session, and more specifically we are going to discuss the important areas through questions of fluid kinematics. And let me tell you, kinematics is one of the scoring and one of the highly weighted topic of entire fluid mechanics. All right. So shall we start? So you can keep your notebook, calculator and pen and pencil so that attempt the questions independently, as many as possible. And in case of any difficulty, you can always chit chat with me through the comment section, right? And you can always connect with me through the mail ID which is there on the top of the screen. And you should join me on the Telegram. My Telegram link is Mechanical by Chandrasekhar. Once you become part of my Telegram channel, you will be getting the notification of various examination. The PDF of this session will also be provided to you through the Telegram channel only. The important updates about the various sessions, and I will also share some important questions for your homework, and you can also share your knowledge through the Telegram channel. So many students are already part of my Telegram group. If you join me on the Telegram, it will definitely help you in improving your performance in your upcoming GATE examination. Hi Maniket, good evening, welcome, how are you? Good to see you, good to see your motivation, good to see your jazba, enthusiasm. So please share the link of this session to all your friends, colleagues and those who are in civil as well as mechanical engineers who are going to prepare for GATE 2024 examination. The session is going to be very useful. So you can join me on the Telegram by using scanning the QR code, or you can join me by using the link mentioned below, or you can search me by the name Mechanical by Chandrasekhar. And for those students who are not targeting GATE 2024, but yes, they are preparing for GATE 2025. It is a long journey. It is having long distance to cover to appear for GATE 2025. Then Richa ma'am will be coming live on 25th of October at 7:30 p.m. and she will be discussing the preparation strategy based on her experience, her knowledge, her understanding about the GATE examination. She will guide you how to make your strategy perfect, foolproof to clear the GATE examination. You just have to register yourself. The registration is completely free of cost, and enjoy the session and utilize the strategy shared by Richa ma'am to improve your preparation, to improve your performance in your GATE examination. But it is my humble request to all of you. I can see so many students who are watching me live. Please write me yes in the comment section, or you can show the love, affection, this heart sign, anything to mark your presence. Please write something in the comment section so that we can start our session. And we will be covering 10 questions like yesterday. Yesterday was the session for fluid statics. And today, hi Mohan, welcome, good evening. Welcome to the session. And there will be a scholarship test tomorrow, 22nd of October. Do join, do attempt this scholarship test. It does not cost you anything. But if you get through the scholarship test, if your performance is very good in the scholarship test, you can get our courses at a discounted price. And even if you are not interested in purchasing our course, not a problem. The scholarship test will help you to practice some numericals which are having the difficulty level as that of your actual GATE examination. And similarly, in today's session, I have brought the questions, hand-picked questions, which are definitely be having the difficulty level as that of your actual GATE exam. All right. Again, for attempting this scholarship test from 9 a.m. to 9 p.m., you have to register yourself, and the link is already mentioned in the description box. Let us start with question number 1. Every one of you, please give it a try and let me know the answer. Everyone, please give the question a try and let me see who will be the first one to give me the correct answer. And I will plan some surprise gift for the one whose performance is consistent and the time management is perfect. The question says a two-dimensional velocity field is given by this expression. A two-dimensional velocity field is given by this expression. It is two-dimensional flow. That is why there are I component and j component, where I and j are the unit vector in the direction of rectangular coordinates, Cartesian coordinates x and y respectively. If the flow is incompressible, what we are supposed to do from where the question is, then what will be the value of the constant? What we need to do is we need to apply the continuity equation for incompressible flow. Do you guys remember? Yes, Ludwig Prandtl. Oh my God, Prandtl is also there. Ludwig Prandtl is famous for, Prandtl बता सकते हैं? Ludwig Prandtl is famous for what? What have he done in engineering? Continuity equation for incompressible flow. If we apply continuity equation for incompressible flow, what is the meaning of incompressible flow? Density is neither be a function of x, nor y, nor z, nor time. Density remains constant throughout the flow. So first of all, you need to equate this expression with the general velocity profile. So you can get u and v. We can get u and v. Yes, thanks for your love, affection. कौन इतने हार्ड साइंस दे रहे हैं? Let me know. Theory of boundary layer. Well done. Yes, C is the right answer. Ludwig had given the correct answer first. So the prize for this question goes to Prandtl. Manike, thoda आप late हो गए. Yes, definitely the correct answer is option C. Let me quickly solve it for those who were not able to solve it. So U is equal to the parameter related with I cap. So U is equal to 10 y cube minus x square y. And what is velocity in y direction? that is 2cxy square. So what is the continuity equation for two-dimensional incompressible flow in Cartesian coordinate system for the incompressible flow? So we can say del u by del x plus del v by del y is equal to 0. What is del u by del x? If you differentiate u with respect to x, then it will be 10, isn't it 10? Then it is minus 2x into y, isn't it? Plus, what is del v by del y? Del v by del y is 2cx into 2y, must be equal to 0. So it will be minus 20xy plus 4cxy is equal to 0, or we can say 4cxy is equal to 20xy. Y is getting cancelled out, x will also be getting cancelled out, then c is equal to 20 by 4, that is equal to 5. 5 will be the correct answer. Well done guys, well done. Those who are not able to solve it, I hope you understood the concept. Continuity equation for incompressible flow is very important expression. Directly or indirectly, the questions are framed. Sometimes how the questions are framed, they ask you to check whether a particular flow is compressible or incompressible. So there are two methods to know whether a fluid flow is compressible or incompressible. One is if the density varies with space or time or both, then it is definitely compressible flow. But if the density does not vary with space and time, then the flow will be incompressible. But if nothing is given regarding the density in the question itself, then what we need to do is we need to check the continuity equation for incompressible flow. If this is getting satisfied, because continuity equation is the mass conservation, for a flow to be possible, mass conservation should always get satisfied. And if the continuity equation for incompressible is getting satisfied, then the flow is definitely incompressible. If it is not getting satisfied, then the flow is said to be compressible. All right. Let us move to the next question. It is not question number 4. This is question number 2. I could not type this equation. That is why I have brought the direct screenshot of the question. Yes, let V and T, V is the velocity vector, velocity is a vector quantity, T is the temperature, which is a scalar quantity. Denote the velocity vector and the temperature in the flow field. The rate of change of temperature experienced by a fluid particle as it is passes through the point x1, y1, z1 at a time t1 is 2.5 degrees Celsius per second. The rate of change of temperature at a time t1 at a point x1, y1, z1 is 4.8 degrees Celsius per second. What will be the value of this quantity V dot del T at location x1, y1 and z1 and time t1 is? Can you solve it, and can you just let me know from where the question is framed? Yes. Now Ludwig, Maniket, what about others? Mohan, everybody please give it a try. Question number 2 on the screen. The question is actually from, कहां से है बताइए? 1 mark for the 1 point for the right guess. You will get 1 point for making the right guess. So wherever you find an option to practice, do not skip that. Always try to keep practicing. The more you practice, even if you are not very much comfortable with the theory concept, once you start practicing the numericals based on a particular concept, automatically you will start enjoying, you will start developing the confidence in the particular concept. So GATE is all about the application of the concept that comes from the theory only. Yes, that is correct, Prantal. The question is from the material or substance derivative. The question is from the material or substance derivative. or total derivative, material or substance or total derivative. So total derivative of any parameter d by dt is equal to partial derivative of that parameter plus v dot del into this parameter. This is called as total derivative, like this. This is called as total derivative of a parameter, or we can call it as material derivative. So if we find out the material derivative of velocity, then that gives the acceleration. Material derivative of velocity is nothing but acceleration. Similarly, we can find out the material derivative of temperature. Small t is the time. Capital T is the temperature. We can find out the material derivative of pressure as well. So if we simplify this, then you will get this expression. So dt by dt is equal to del t by del t. Partial derivative, that is called as local or convective part, local or unsteady part. And this portion is called as convective or advective part. So del t by del t plus v dot del into t. So here velocity and temperature denotes. So the total derivative, the rate of change of temperature experienced by the fluid particle as it is passing through the point is given as 2.5 degrees Celsius per second. So dt by dt is equal to 2.5 degrees Celsius per second. The rate of change of temperature at a time t1 at a point x1, y1, z1. So that is partial derivative of t 4.8 degrees Celsius per second. So if you simplify this, put these values here. If you will put these values here, what will you get? So the total derivative is 2.5 is equal to partial derivative 4.8 plus v dot del into t. This is the expression. So v dot del into t is equal to 2.5 minus 4.8. So it will be minus 2.3 degrees Celsius per second. Isn't it? Minus 2.3. Yes, 2.3 will be the correct answer. Prantal. Well done. Maniket. What about others? 2.3 will be the correct answer. It should be minus 2.3. Is this clear to everyone? In degrees Celsius per second. V से क्यों मल्टीप्लाई होगा? ये यही तो पूछा है. V डॉट डेल टी तो पूछा है. यही तो पूछा है. हमारे को यही तो पूछा हुआ है. यही एक्सप्रेशन. We are asked with this expression only. यही तो एक्सप्रेशन पूछा है. क्लियर? V डॉट डेल होता क्या है? इसका डॉट प्रोडक्ट पता है क्या? V होता है वेलोसिटी वेक्टर u i कैप प्लस v j कैप प्लस w k कैप एंड डेल ऑपरेटर इज इक्वल टू i कैप डेल बाई डेल x प्लस j कैप डेल बाई डेल y प्लस k कैप डेल बाई डेल z. There is a difference. Try to understand. There is a difference between v dot del and del dot v. There is a difference between v dot del and del dot v, isn't it? Del dot v. They are not same. V dot del is u into del by del x. This is u into del by del x plus v into del by del y plus w into del by del z. That is v dot del. And what is del dot v? Del dot v is del u by del x plus del v by del y plus del w by del z. They are not same. They are not same. ये क्वेश्चन जूम नहीं हो सकता है क्या? थोड़ा करके देखता हूं. ये एक्चुअली फोटो है, क्वेश्चन की फोटो है, इसलिए आपको थोड़ी सी इस क्वेश्चन में डिफिकल्टी होगी. आई डू अंडरस्टैंड. जस्ट गिव मी अ मोमेंट. आर यू एबल टू सी नाउ? अभी दिखाई दे रहा है? हाँ प्रांटल, yes, this equation is valid for both. Shall we proceed to the next question? This is how you can find out the expression of acceleration. तो अगर इसको मैं थोड़ा सा और एक्सपेंड करूं, ध्यान दीजिए, थोड़ा सा और इसके बारे में मैं इंफॉर्मेशन देना चाहूंगा. लुक, हम बोल सकते हैं dt by dt इज इक्वल टू डेल टी बाई डेल टी प्लस, क्या मैं बोल सकता हूं, u इंटू डेल बाई डेल एक्स प्लस v इंटू डेल बाई डेल वाई प्लस w इंटू डेल बाई डेल जेड मल्टीप्लाइड बाई t. सो क्या मैं बोल सकता हूं, दिस इज इफ वी टेक t इनसाइड, if we take t inside the bracket, then can we say it will be u into del t by del x, del t by del y, del t by del z. This is the expression for total derivative of temperature with time. That is the expression. So this expression can be obtained like this also. As temperature is a function of x, y, z and t, as temperature, and if we differentiate with respect to time, if we differentiate this with respect to time, left hand side is a single parameter, so total derivative with time is on the left hand side. What is the right hand side? We can say del t by del x into dx by dt plus del t by del y partial derivative into dy by dt plus del t by del z into dz by dt plus del t by del t into dt by dt, isn't it? This will be the expression. Do you get it? And what is dx by dt? That is u. And what is dy by dt? That is v. dz by dt, dz by dt, w, dt dt getting cancelled out. So dt by dt is equal to, that is another way of getting the same expression. So u into del t by del x plus v into del t by del y. If you do not remember the material derivative, then also you can develop the expression by assuming that temperature is a function of space as well as time, isn't it? Plus w into del t by del z plus del t by del t. So that is nothing but del t by del t can be written here, del t by del t, plus this is nothing but v dot del into temperature, isn't it? So that is another way. So that is how it is related. Let us move to the next one, question number 3. Shall we proceed to the question number 3? This is your question number 3. Everyone, please give it a try. And if you are not able to solve it here, then try the question at home again. Yes, give it a try and let me know the answer. Ludwig is every time giving me the correct answer. अब किसको जूम कर दूं? अब ठीक है, मनिकेत ज्यादा वो नहीं होना चाहिए, अपॉर्चुनिटिस्टिक, सॉरी, ज्यादा उम्मीद मत लगाओ. अब तो कुछ नहीं है, सब ठीक तो है. आपको दिखाई नहीं दे रहा? ऑप्शन भी नहीं दिखाई दे रहे? अभी ठीक है? अभी ठीक है क्या? Is it fine now? इज इट बेटर नाउ? अच्छा, आई प्रॉब्लम क्या आप मोबाइल से देख रहे हैं क्या? हाँ, इन ए सिंपल काउट फ्लो, क्या होता है काउट फ्लो? व्हाट इज द काउट फ्लो? Flow between two parallel plates, flow between two parallel plates out of which one is moving. So try to avoid using the mobile for attending the classes. Maniket, in the long run, it will impact your eyesight. So always, you should always take care of few things. If you are more into attending the live classes or online classes, then always use a computer, desktop or laptop and maintain a distance. Maintain a proper distance between your eyes and the screen. And you can use the screen cover as well, screen guard to your laptop or computer. So it will help you to keep your eyesight better for long. Yes, flow between two parallel plates of which one is moving, that is called as Cout flow. And what is simple or plain Cout flow? Simple or plain Cout flow means when the fluid, the flow of the fluid is only due to the moving plate, then it is called a simple or plain Cout flow when dp by dx is 0. When dp by dx is 0. So the velocity profile will be linear. Yes, what is the answer? In a simple Cout flow apparatus, from the question it looks like the question must be from the fluid dynamics, flow between parallel plates, but it is not from the dynamics, it is from the kinematics only, because the question is to find out the vorticity. The question is about vorticity. What is vorticity? Vorticity is twice of angular velocity. Vorticity is twice of angular velocity. Yes, what should be the answer? The gap between the parallel plates is filled with a liquid of density L. One plate is moving, top plate is let us say moving, the bottom plate is let us say fixed. Top plate is moving, bottom plate is fixed. The gap between the plates is filled with a liquid of density L and dynamic viscosity mu, and one plate is dragged at a velocity of capital U. The velocity of the top plate is capital U parallel to itself, while the other plate is fixed. This is the fixed plate. The magnitude of vorticity at a point in the flow is. Can you let me know the velocity profile? If we assume it as plain Cout flow, can you let me know the velocity profile? The options are, option A is mu upon LH square, option B is 0, option C and option D is U by H. Can we assume the velocity profile to be linear? If nothing is given regarding the velocity profile in the fluid, can we say small u, this is y let us say, so u is equal to capital U into y by h. Can we assume the velocity profile to be linear? U is equal to capital U y by h, isn't it? Now what is the vorticity about z axis? Nobody has given me the answer yet. No one had given me the correct answer yet. Prantal, कुछ confusion है? So it is a function of y. Can we say u is not a function of x? It is not a function of x. U is not a function of x, but yes, it varies in y. U is equal to 0 at y is equal to 0. At y is equal to h. U is equal to capital U. It is linearly varying. So vorticity about z axis is twice of omega about z axis. And what is omega z? Twice of omega is equal to z then del x minus del y. So it will be del v then del u. That is vorticity about z axis. That is the vorticity. So can we say v is the velocity in y direction? V is equal to 0. Velocity in y direction will be 0, but velocity in x direction is a function of y. It is only velocity in x direction. There is no velocity normal to the x direction. So del v by del x will be 0 because v is equal to 0. So del v by del x is equal to 2 into what is minus del u by del y? Del u by del y is u by h. So minus capital U by h. Isn't it? Sorry, twice of angular velocity, and angular velocity will be, what is angular velocity? Angular velocity is half of del v by del x minus del u by del y. So it is half of 2 into 1 by 2 into minus u by h. So minus u by h will be the value of vorticity about z axis. अभी ठीक है ना? वॉर्टिसिटी होता है ट्वाइस ऑफ एंगुलर वेलोसिटी, वॉर्टिसिटी होता है ट्वाइस ऑफ एंगुलर वेलोसिटी. सो ये 2 और हाफ कैंसिल आउट हो जाएगा, तो वॉर्टिसिटी का जो एक्सप्रेशन होता है, द एक्सप्रेशन फॉर वॉर्टिसिटी अबाउट जेड एक्सिस इज डेल वी बाई डेल एक्स माइनस डेल यू बाई डेल वाई. ये वॉर्टिसिटी का एक्सप्रेशन होता है. दिस इज द एक्सप्रेशन फॉर वॉर्टिसिटी अबाउट जेड एक्सिस. सो द करेक्ट आंसर फॉर दिस वन इज ऑप्शन डी. D will be the right answer. Option D will be the correct answer. Is this all clear? Question number 3. Anybody is having any doubt? Do let me know. Let us move to the next question. Before moving to the next question, let me give you an important information. This is already over. 14th, the first mega mock test is already over. Tomorrow, कैपिटल यू तो कैपिटल यू ही है ना मनिकेत, ये कैपिटल यू है, किसका वैल्यू पुट करना होगा? स्मॉल यू अलग चीज है. स्मॉल यू इज वेरिएबल, स्मॉल यू इज अ फंक्शन ऑफ एक्स, कैपिटल यू इज द वेलोसिटी ऑफ द टॉप लेयर. सो डी यू, इसको सॉल्व करेंगे, डी यू बाई डी वाई दैट इज इक्वल टू कैपिटल यू बाई एच. कैपिटल यू तो कांस्टेंट है, it is a constant value, it is not a function of y. Small u is a function of y, right? So we are having the mega mock test. You just have to register yourself for the mock test, and based on your performance in the mock test you can get our test series with the discounted price. So tomorrow will be the result for this first test, and the next test will include the fluid mechanics, strength of materials and power plant. These will be the subjects. Please prepare yourself, and the pattern of the test will be as same as the gate pattern. All right, so let us move to the next question now. This is wonderful question. Question number 4. It is not 14. Question number 4. Try to solve this question. Question number 4 on your screen. Now I am not going to solve it. I am not going to solve it. You are supposed to give me the answer. Every one of you, please give it a try. Every one of you, please give this question a try. The question might look a little confusing or complicated, but once you read the question, once you will understand the question, you will find it very simple. All right? करिए जरा ट्राई, and let me see whether my answer will be matching with yours, because I am also not very much confident whether I have done it correctly or not. There is some fluid entering into the control volume, there is some fluid leaving from the control volume. Prantal, Maniket, please do solve it and let me know the answer. You need to find out the rate of change of mass in the control volume at the instant where the parameters are given in the figure. Yes, give it a try. So let me help you. If fluid enters into the control volume, this is the control volume. This is our control volume. The fluid is entering into the control volume at section, let us say, at the inlet port, which is denoted by subscript I. The fluid is entering at I. The velocity at inlet I is 3 meter per second. The density is 5.5 and the area, inlet area, is equal to 0.2. So can we say from the mass conservation, from the conservation of mass, can we say rate of change of mass in the control volume is equal to mass flow rate entering into the control volume minus mass flow rate leaving from the control volume. That is the rate of change of mass in the control volume. Mass flow rate entering minus mass flow rate leaving, and the leaving ports are O1 and O2. So can we say mass flow rate entering is m dot I, inlet port, minus, can we call it as m dot 1 m dot 1 plus m dot 2 at outlet. That is dm by dt in the control volume. That is dm by dt in the control volume. So what is the mass flow rate? How to write the mass flow rate? Mass flow rate, is the mass flow rate a scalar or a vector quantity? It is rho into A into V, or we can call it as rho into Q. Mass flow rate is rho into A into V. Will the mass flow rate be scalar quantity or a vector quantity? Mass flow rate is rho AB, density is given, velocity is given, area is given. Here in A into V or discharge, where Q is equal to A into V, and area and velocity must be perpendicular to each other. सेम कॉन्सेप्ट यूज कर रहे हैं, वेरी गुड. मनिकेत पर कितना टाइम लगाएंगे, कितना देर वेट करूं आपका? जल्दी करिए और मुझे बताइए व्हाट शुड बी द आंसर. एंड प्रांटल आल्सो प्लीज गिव इट ए ट्राई. बाकी लोग तो सिर्फ प्रवचन सुनने आए हैं बाबा जी के, बाकी लोग तो पार्टिसिपेट कर ही नहीं रहे. व्हाई यू गाइज आर नॉट पार्टिसिपेटिंग? लेट मी टेल यू, if you do not practice, if you do not participate, then you do not deserve to win. In expression of discharge, velocity and area must be perpendicular to each other. Why? Because A is called as the flow area, the area which is normal to the flow, and V is called as flow velocity, that is in the direction of the flow. So area and velocity must be perpendicular to each other. हाँ, accumulation unsteady flow है प्रांटल, इट इज अनस्टडी फ्लो, दैट इज वाई मास फ्लो रेट एक्यूमुलेट ही तो होगा. यही तो पूछा है क्वेश्चन में, जब यही तो है रेट ऑफ चेंज ऑफ मास इन द कंट्रोल वॉल्यूम, दैट इज द एक्यूमुलेशन. सो द मास एक्यूमुलेशन इन द कंट्रोल वॉल्यूम इज मास इन माइनस मास आउट, एज सिंपल एज दैट. 3.95 आ रहा है. रुकिए जरा, सब्र कीजिए. देखिए, सो कैन वी राइट dm by dt in control volume? So here velocity is having this direction and area is this. If we want velocity and area perpendicular to each other, then vi will be 3 cos 45. Area and velocity must be perpendicular to each other. Mass flow rate is not a vector quantity. Mass flow rate is a scalar quantity, but area and velocity must be perpendicular to each other. So rho I is 5.5 into area, that is 0.2, into 3 cos 45, that is mass flow rate entering, minus what is the mass flow rate leaving? there are two points where it is leaving. Density is 5 into area is 0.15 into 2 cos 30 plus the third point O2 is density is 5 into area will be 0.1 into velocity will be, velocity is making an angle 20 degree with the area and velocity must be perpendicular to each other, so it will be velocity 1 cos 20. So this will give you the answer. Can you quickly solve it? 5.5 into 0.2 into 3, 5.5 into 0.2 into 3, 5.5 into 0.2 into 3 into 3 cos 40, that is 2.5279, 2.526 minus then 5 into 0.15 into 2 cos 30, 1.299 plus 5 into 0.1, that is 0.5, 0.5 into cos 20, that is 0.4698, 0.4698. So then plus 1.299, 1.299 minus 2.526, 0.5757, 0.757 kg per second. Do you get it? This should be the answer. 0.757, 0.757 will be the correct answer. Are you getting it or not? Everybody, please give me yes. And do not forget, if you like the level of the question, if you like the session, if you are enjoying the session, please do not forget to like this session and do not forget to share this session to all your friends and colleagues. अच्छा, ऐड कर दिया था. Subtract होगा ना, in minus out will be the accumulation. So this will be the answer. Let us move to the next question. Question number 5. Beautiful question again. Question number 5. And subscribe our BYJU'S YouTube channel. Tomorrow at 11 a.m. I will be discussing the question from the Bernoulli principle, fluid dynamics. Again, 10 important questions we will be discussing. Let us move to question number 5 quickly. Velocity vector in meter per second for a 2D flow is given in Cartesian coordinate system as this. Symbol bear usual meaning. X is the direction, X is the X and Y are the coordinates. At a point in the flow, the X and Y components of acceleration vector are given as 1 meter per second square is minus 0.5. Ax, that is equal to 1, which is equal to u into del u by del x plus v into del u by del y plus del u by del t. Because velocity is not a function of time, so it is a steady flow. Can we say the flow is steady? So local acceleration will be 0. So can you find out? Compare this expression with ui cap plus vj cap. So can we say u is equal to x square by 4 and v is equal to minus xy by 2. U is equal to x square by 4 and v is equal to minus xy by 2. Acceleration is given as 1, acceleration in x direction. So we can say 1 is equal to u, that is x square by 4 into del u by del x, that is 1 by 4 into 2x plus v, that is minus xy by 2 into del u by del y, that is 0. Del u by del y is 0. So this term will be 0. So this will give you 2 to the 4. So we can say x cube by 8 is equal to 1. So what is the value of x? That will be 2. The point x will be equal to 2, isn't it? Similarly, ay, What is the value of ay? That is minus 0.5 is equal to u into del v by del x plus v into del v by del y. So put the value, that is equal to minus 0.5 is equal to u is x square by 4 del v by del x minus y by 2 plus v minus xy by 2 into del v by del y, that is minus x by 2. What you will get? Minus 0.5 is equal to minus x square y by 8, then plus x square y by 4, isn't it? How much is that? Minus x square y by 8 plus x square y by 4. So it will be minus x square y plus 2x square y upon 8, isn't it? So it will be x square y by 8, isn't it? X square y by 8 is equal to minus 0.5. So x square y by 8 is equal to minus 0.5. Put the value of x, x is equal to 2. So it will be 2 square into y by 8 is equal to minus 0.5. What is the value of y? Y is equal to minus 0.5 into 8 by 4. So it is 5 into 2, that is minus 1. Y is equal to minus 1. Are you getting? X is equal to 2 and y is equal to minus 1. The velocity magnitude at the point is, now we need to find out the velocity. What is the velocity? What is u at x is equal to, at x is equal to 2 and y is equal to 1. Y is equal to minus 1. What is the value of u? What is u? U is equal to x square by 4. X square by 4, that is equal to 1. 2 square by 4, that is 1. U is equal to 1. And what is v? V is equal to minus xy by 2 minus xy by 2. Put the value, minus x is 2 into minus 1 by 2. So it will be 1. X is equal to, u is equal to 1 and v is also equal to 1. So magnitude of velocity is under root of u square plus v square. So that is under root of 1 square plus 1 square. Root 2 will be the answer. 1.414 meter per second will be the magnitude. 1.414 meter per second will be the magnitude, isn't it? 1.414 will be the answer. Do you guys get it or not? Root 2, either you can say, call it as under root of 2 or you can call it as 1.414 meter per second will be the answer. Please do let me know if you understood the question or concept. If you have any doubt, any difficulty, anything to ask, you are most welcome. I will share the PDF of this session to my Telegram channel. So go through this PDF once again, try to solve these questions once again independently without any help. Then you become more comfortable, more confident. Let us move to the next one, question number 6. Beautiful question. The question is actually not about the kinematics. It is more about the differentiation. It is more about differentiation rather than it is about kinematics. A two-dimensional incompressible flow is defined by this velocity component in meter per second as given by this. U is equal to minus cy x square divided by x square plus y square and v is equal to cx divided by x square plus y square. If the value of the constant c is equal to 0.1 meter square per second, the numerical value of vorticity at a point x is equal to 1 and y is equal to 2 meter is. What will be the vorticity? What is the vorticity? First of all, you should know the formula for vorticity about z axis. That is twice of omega z. We can say that is excuse me. This is the vorticity. Can you let me know? Can you give it a try? Can you guys give it a try? Question number 6. Now our objective is to find out del v by del x and del u by del y. Can you find out del u by del y? Look, this is the velocity. U is given by this expression and v is given by this expression. So this is our equation number 1. We will put the value in equation number 1. This is our equation number 1. So first of all, find out del v by del x. Del v by del x. So del v by del x is equal to, c is constant. Then what we will do? C is constant. Then we can say x into differentiation of x square plus y square to the power minus 1. So it will be minus 1 into x square plus y square to the power minus 2 into then differentiation of x square, that is 2x. This then plus we can say 1 upon x square plus y square is taken constant. Then differentiation of x, that is 1. This will be the expression, isn't it? Del v by del x. So how much it will be? Del v by del x is equal to c into, it will be minus 2x square upon x square plus y square whole square plus 1 upon x square plus y square. Or we can say del v, or we can write del v by del x is equal to c. If we take x square plus y square whole square as the LCM, then it will be minus 2x square, then it will be plus x square plus y square, isn't it? So it will become minus 2x square plus x square is minus x square. So it will become y square c multiplied by y square minus x square upon x square plus y square whole square. Please do acknowledge if you are getting this value for del v by del x. If you guys are getting this value, please do let me know. माइनस 0.4 कैसे आया? आपने किया क्या? What did you do? Now similarly, if we talk about del u by del y, u is given by minus cx, sorry, minus cy upon x square plus y square, that is u. So del u by del y, if we want, then we will say minus c. Let me take minus c as common, then y into, it will be minus 1 into x square plus y square to the power minus 2 into 2y, that is first expression, plus 1 upon x square plus y square, then differentiation of y is 1. This will be the expression. So it will be minus c, then it will become minus 2y square, upon x square plus y square plus 1 upon it is whole square plus 1 upon x square plus y square, isn't it? So it will be minus c into, if we take x square plus y square whole square as the LCM, then minus 2y square, it will be minus 2y square, then plus x square plus y square, isn't it? So what it will become? Minus c into minus 2y square plus y square, that is minus y square. So it will be x square minus y square upon x square plus y square whole square. That is del u by del y. Del u by del y is this and del v by del x is this. So if you subtract these two, del v by del x minus del u by del y will be how much? What is del v by del x? Del v by del x, del v by del x minus del u by del y. So del v by del x is how much? Del v by del x, c into y square minus x square, c into y square minus x square upon x square plus y square whole square. Then minus, then it will be minus c into what is del v by del u by del y, x square minus y square upon x square plus y square whole square. This will is the expression. So it will be c plus c. So if we again see common, then it will become x square plus y square whole square. Then it will be y square minus x square plus x square minus y square. What is the answer? What is the answer? Isn't it 0? Isn't it 0? Are you getting it is 0 or not? Tell me if you have anything to ask. You are most welcome. Why you guys are getting 0.4? My answer is 0. I am getting it is 0. बताइए, any doubt? Everyone, it is an open session. You can raise your concern. You can ask me if you feel any difficulty, if you face any doubt. You can share. Common mistake. पर ये सही है क्या? I am also not very much confident whether this answer is correct or not. आपके agreement से, if you will agree that whatever I have done is correct, then I will feel confident. Is it correct or not? Prantal, आप तो अच्छा परफॉर्म कर रहे हैं, आप बताइए, is this the right approach? Did I commit any mistake in differentiation? Because I am also not very much comfortable in differentiation and integration. I am not very much comfortable in differentiation and integration because we rarely use now. But you guys study the mathematics, the differentiation. Is the differentiation correct for u and v? Differentiation correct है या गलत है? All right, thank you. Let us move to the next one. Yes, there is an important announcement. Are you guys aware? So many students face difficulty in memorizing the formula. In the back of their mind, it is always a fear whether they will be able to recall the formula in the examination or not. So for this fear, to get rid of this fear, we are bringing an important and unique series. Revision of the formula is very tedious and very boring task. But what we will do is we will test your memory through the questions. We will discuss, we will frame the questions in such a manner that each and every question will brush up your memory only. It is not about numerical, it is not about calculation. So only the formula will be brushed up through this formula memory test. It is a unique and interesting trick to memorize your formula through questions. So the series is going to be started from 25th of October. If you have not subscribed our BYJU'S YouTube channel, please do it right away, because the first session will be on 26th of October at 8:30 p.m. That is about the strength of materials, which is common for civil and mechanical. And the next day, 27th of October at what time? मैंने टाइम क्या है 8:30 and 8 p.m. 8 p.m. I will be having the fluid mechanics session for civil as well as mechanical, both branches. All right. So this is the entire schedule for mechanical engineering. Similarly, there is a schedule for civil engineering branch also. So the time is almost over. We have completed only 6 questions, but I wanted you to understand the in-depth conceptual clarity for the question. That is why I was a bit slow. So let me give you the remaining question as assignment. Try to solve these questions and bring me your answer. And if you have any difficulty, you can discuss with me. If you have any doubt, you can always discuss with me either through my mail ID or my Telegram channel. We are running a crash course for GATE 2024 aspirants also, and we have just started, launched our Vision GATE 2025 and 2026 batch for second year and third year students who are going to prepare for GATE 2025 and 2026. If you have any query regarding these courses, you can call the mentioned number. Thank you, Prantal. मैंने तो अभी बोला नहीं मैं जा रहा हूं. Why did you say thank you? There are some more assignments. Try to solve these questions. This is another assignment, simple questions, but yes, the concept clarity is important. These are your assignment question. So please give them a try and bring me the solution through my Telegram channel, or I will share the PDF of this session, don't worry. And tomorrow at 11 a.m., it is not PM. Tomorrow at 11 a.m. in the morning, I will be coming live with dynamics. Tomorrow at 11 a.m. All right. Thank you guys. Thank you for joining in and giving your 100% participation in the session. This is the entire schedule for 10 Ka Dam series, where we are discussing not more than 10 questions, but each and every question is, I promise each and every question is too brilliant to improve your fundamentals. This is my contact email ID, and you can join me on the Telegram also. That is all from my side, guys. Thank you very much. Once again, have a great Sunday. Take care and Jai Hind.